I'm back, guys. Hopefully you're not sick of me yet. Okay, we're still on the virus alert, so you're stuck with me doing videos about class. I know I'm much better in person, but we're gonna have to deal with this right now. Anyways, I got some really great stuff to talk about because one of my favorite things to talk about is the glacier. That's glaciers for those of you that aren't French. So, glaciers. Really, just a couple things you got to keep in mind throughout this whole spiel that I'm gonna have on glacier. And by the way, that's a ice sheet glacier behind me. We're gonna talk about two types of glaciers: ice sheet glaciers and also glaciers that form at high elevations called alpine or valley glaciers. We're gonna talk about both types. When it comes to glaciers, really, what do they do with the ground? First of all, one thing you got to keep in mind: when they leave stuff behind, it is completely messed up. See, wind, streams, they sort it out. As the water slows down, the bigger particles settle, the medium particles, the smaller ones, horizontally, big, medium, small. That's called sorting. With sand dunes, all sand grains, all silt grains, maybe even clay, if there's hardly any wind at all. It gets sorted out with wind and with running water. Not glaciers. Glaciers are just like gravity. Gravity just dumps things falling from a cliff. It ends up at the bottom of a cliff. It's not going to be sorted. Glaciers, unsorted sediments. What are glaciers? They are nature's plows. So a glacier, seriously, is going to form, start usually from the north, and when we were first invaded, about 1.8 million years ago was our most recent glaciation, and it ended about 10,000 years ago. In your Earth Science reference tables on page 8 and 9, it is actually referred to as the Pleistocene epoch of time in which we had our last glaciation. 1.8 million to about 10,000 years ago. Page 8 and 9, specifically on page 9, the Pleistocene epoch. In fact, it says in the reference table, the advance and retreat of the last continental ice. Easy to remember, ice, place. Ice, place. What did the glacier do? I imagine it like this. It came down from Canada and it went. I'm sure if you were around back then, you would have heard that. It scraped up the ground, it picked up everything in its path, and then climate started to change. And it got warm, the glacier went back to where it came from, and it just left all of its stuff in the ground. Sometimes clumps formed underneath it. We'll talk about those. This video is going to be a little bit longer than the last few because there's a lot to talk about here. And it's just going to be all messed up. It's going to be scratched and polished up. They're going to be sub-rounded. See, streams are going to be really rounded, not glacial stuff. Glacial stuff is going to be sub-rounded, kind of round. But look at all the scratches on that bad boy. Because it was tumbled in the glacier, and then it was just dropped, along with everything else, unsorted sediments. And the valleys, U-shaped valleys, where the glacier just gets crammed through the valley. It makes like a giant ice cube, gets a little bit worn over time, not V-shape. V-shape is with streams, these are U-shaped. So we're going to lift this up. That's, oh, by the way, that ice sheet, only two of them left in the world today. Greenland and Antarctica. Only places that have ice sheets today. Not like we had during the Pleistocene epoch of time, where it invaded a great portion of the northern U.S. and almost entirely New York State. We'll talk about that in a second again. So now we're going to look at an alpine glacier. With the alpine glacier, let me get my pointer here. Okay, well, the glacier ice forms because of high elevation, colder temperatures. And what is a glacier? A glacier isn't a bad snow day. A glacier is ice that's supposed to stay year after year after year. That's why in the continental U.S., in a place called Glacier National Park in northern Montana, northwestern Montana, when it comes to that, we have glaciers now, but those glaciers, by 2023, 3 years from now, might not be there anymore. And those are the only glaciers in the continental U.S. Why? Two things. It's cold up in northern Montana, but it does warm up during the summer. What keeps the glacial ice is the high elevation. So you have these alpine or valley glaciers. And what they do is they move like a frozen river through the valley, carrying sediment with them. So as they move, sediment builds up on the sides of them. So once again, it's like a shovel. If you took, and you wanted to shovel your driveway, and you took a shovel and you put it down the middle of your driveway, you're going to get heaps of snow on each side of that shovel. And where else are you going to get a heap of snow? At the end. Think of the shovel as the glacier. Where's it going to pile all the rocks? Along the sides and at the end. Along the sides are called lateral moraines. Moraine is a word for a bunch of unsorted sediment associated with a glacier, usually in a big mound. These are called lateral moraines, like Area B is showing, okay? And then at the end, which we can't see, we're going to have what's called an end moraine, and the last one's called the terminal moraine. What happens is giant chunks get chewed off of these mountains, and when it forms, it's almost like if you broke glass, and it gets like these sharp edges. These sharp edges are actually given the name called arêtes. You don't have to know the name arête. What you do have to know is that the glacier produces these sharp ridges. Next slide, please. And you can see that there's all different sediments. This is what you would have in a moraine situation. All different sediments, and they're all called unsorted, unlayered, messed up. Don't miss this. You're going to get a question in June on it. Unsorted sediments, glaciers. Unsorted, unlayered, messed up. We got a lot of those throughout New York State. Next slide, please. Yours truly took this picture, okay, from Glacier National Park. We're flying over in a helicopter. By the way, this is called the glacier, duh. Where this is a snow line, guess what that's called? The snow line. And this is called the meltwater or outwash. And that's Area C. And you can see that there's arêtes. Actually, the sharp mountains are called horns. At one time, this was all mountain. And it's all been chewed up as the glacier's working its way through the valley. And then, of course, the glacier has receded. It's gone back due to climates getting warmer. Next slide, please. This is one of the most famous carved glacial peaks in the world. This is actually called the Matterhorn. And the glacier came on each side of it. This was a rounded mountain. The glacier tore off this side, this flank, and we get this very, very sharpened peak, which is called a glacial horn, evidence of valley or alpine glaciers. And the most famous in the world, like I said, called the Matterhorn in the Swiss Alps. Next slide, please. Yours truly again took this picture. This is from the helicopter flying over glacier. You got the horn, you got the arêtes, and what you have is something that's really cool. The glacial ice is formed in here, and when it melts, it's not pretty. It takes a gouge, like a bite, out of the mountain. In doing so, it forms like you taking your hand and grabbing a chunk of the mountain. It forms a semicircular gouge called a cirque. Do you have to know the word cirque? No. Do you have to know that the word cirque is associated with glaciers? Yes. Just like arêtes and horns. Next slide, please. You don't want to be caught in one of these. This is called a crevice, but you have to make it more exciting than that. It's called a crevasse. Crevasse. And these are where the glacier has cracked. And they can go down hundreds of feet. Remember in the Mount Everest video, guys? Where they had to cross the crevasses with those ladders? Pretty shaky work there. But what is caused by the glacier actually cracking? We think of a glacier as very smooth and silky. At least I did. When I went to Glacier National Park, I couldn't believe it. A glacier is like a dirty parking lot filled with sediment. It does glisten in some places because it is made out of ice, but the ice has trapped within it all this unsorted rock matter that has accumulated as it's gone through the valley. So that's what it ends up being very stiff and studded with materials, and it could crack as it moves and it forms these crevasses. Next slide, please. Now this is pretty cool. When the glacier goes over sediment, it actually takes its rocks at the bottom and goes over those rocks. And what it forms is what's called glacial grooves or striations. Here they are, glacial grooves or striations. This is from Lockport, north of us, and a place called Outwater Park. I was actually at a baseball game there. I said I'm going to check out some things in the park, and this was actually in the parking lot, so I did take a piece of their parking lot away, but it's for a good cause. So, These are those glacial striations. Now, what's cool about glacial grooves and striations? If the bedrock hasn't moved, that's a big if, then you can actually tell the north-south or east-west direction that the glacier was moving in. And if it is north-south, most likely it came from the north and it recession, when it melts, back to the north from the south. Next slide, please. This is a really cool spot. This has been my field trip for the last 22 years. This is our last stop, and we would have stopped here this year if indeed we get to go. We'll see, still in the distance. Anyways, this is called Chimney Bluffs. Now, Chimney Bluffs is a glacial glob that forms underneath the glacier. The glacial glob is actually called a drumlin. I'm going to go to the next slide so you can see what a drumlin looks like. We're actually next slide after that. We'll get back to that one. Next slide. And right here is what's called a drumlin. Now, what a drumlin is kind of like a sand dune, but it's not a sand dune because it's a glacial dune. And this is when the glacier's going over the ground, and it actually, it gets like a bunch of stuff stuck underneath it. And because it gets stuff stuck underneath it, what the glacier does, the glacier continues to move forward. And as it continues to move forward, it makes this tapered hill of glacial till. How can you tell that it was made by a glacier? Simple. It's unsorted and unlayered. A glacier put it there. And also, unlike a sand dune, remember the Barcon dunes? They have their gentle slope and then their steep slope off the back. This tends to be steep and then gentle as the glacier tapers it away and makes this glacial dune. Now, this glacial dune is like, I don't know if you guys have cats, but you know how a cat sometimes eats the wrong thing? And it's like, and then it hocks out a hairball? Well, this is kind of like the glacier hocking out a chunk of material in which it smooths it out then after it hocks it out, and this is what's called glacial drumlins. Now we're going to go back to Chimney Bluffs. Stuff's awesome. All right, here's Chimney Bluffs, back to it. What we're actually looking at, because the glaciers came from the north, and this is the northern edge of Lake Ontario. Okay, I should say, no, this is the southern edge of Lake Ontario, but the glaciers came from the north and forming it. We are looking at the butt end of these glacial drumlins. What has happened over the last 10,000 years, since the glaciers left the area and went back north, is this thing has been chewed up. Now, how can I tell it's glacier? By the way, these peaks, they're like 260 foot high from the bottom beach area of Lake Ontario. This is so cool. It looks like the Dakota Badlands. How can I tell it's glacier? I can tell it's glacial because it's all, you guessed it, unsorted. All different rocks, all different sizes, all over the place. Why has it got chewed up so much? Because it's weakly deposited. It's weak. It's not like solid sandstone. It's just all these different rocks and mud just kind of compacted together because it was left there by the glacier, and it's been torn apart pretty well. And as it gets torn apart, you can see that it forms these spires that are just absolutely really cool, unsorted. How can we tell they're drumlins? Well, we can from space. We can see the teardrop effect, can see the direction of the glacial movement. It's very cool. Next slide, please. This is really interesting. As a glacier moves, both valley glaciers, but mostly associated with ice sheets, what happens is the glacier actually, due to friction, partially melts into cracks that are in the ground. As it partially melts into cracks in the ground, the glacier forms like fingers of ice that go in the ground. I'm sure you've all seen an icicle hanging from a gutter, which is made by water partially melted, freezing, melted, freezing. Well, what happens is, think of my arms right now as fingers of ice, and my body is the main part of the glacier. And what happens is, as the glacier went back home, because of warming climate, the ice sickles of arms snapped off in the ground. You are looking at the top part of that icicle, which is usually the biggest part, and it goes down to a point. These icicles, some of them hundreds of feet deep, were left in the ground. Well, what happens when the climate warmed? This is in Minnesota, land of 10,000 lakes, supposedly well, thousands of them, I don't know if there's 10,000. They form like a top part called a kettle. These are called kettle lakes. They are glacier lakes. How do we know? They're super deep because what's happened over time is all the ice melted, leaving all the water, and all the sediment settled to the bottom, forming these super deep, super round lakes called kettle lakes associated with glaciers. Next slide, please. Glaciers are the only force of nature that can leave giant boulders except for humankind's bulldozers. So glaciers are nature's bulldozers. A stream is not going to leave an errant rock like that. That rock is totally erratically placed. It is nowhere where it's supposed to be. In fact, that rock could have came from a distant land, far away. It might not be at all like the other rock types. It is called a glacial erratic. Most people just refer to it as a BFR. Big freaking rock. That's what it is, right there. All right, next slide. And this shows another BFR, large boulder. We're going to read this. Large boulder the size of a small boulder is completely blocking eastbound lanes. Not sure what large boulder the size of a small boulder means. Highway 45. So here we go. This is called the glacial erratic. Glacier left it there, and I guess they decided to leave it there for nostalgia. Pretty cool. Next slide. There's our drumlet. Now, this is cool. There's Cape Cod again. I told you I was going to get back to Cape Cod. Both Cape Cod and Long Island are the furthest extent of the ice sheet that covered us during the Pleistocene epoch of time. Because they're the furthest extent, it was the you better be listening. Are you sleeping? No. Listen, just almost done. The furthest extent of the glacier is Cape Cod and Long Island. So I think this is really cool because Cape Cod and Long Island today has some of the most expensive real estate in the world. The Kennedys in Long Island, the Hamptons area, super expensive real estate. That real estate was not here 1.8 million years ago. Between 1.8 and 10,000, those things that were sandbars, which are mostly submerged by water, got sediment piled up on them due to the last plowing of the glacier, and most of Long Island and most of Cape Cod today are unsorted, unlayered stuff left by a glacier. It was the terminal part of the glacier, its very end, so we call it a terminal moraine. Next slide, please. This is pretty cool. Just going to show this real quickly because sometimes things could get messed up. Because glacier stuff's supposed to be unsorted. So we're not going to focus on this, but I just wanted to show it. This thing that looks like a snake, this is actually a stream that was underneath the glacier. I don't know if you guys have ever seen like there's a thin layer of ice in your driveway and there's water running underneath your driveway. Well, that happens with a glacier. There's like meltwater underneath the glacier. Now, since it's a stream associated with a glacier, the sediment is still scratched and polished, unlike running water sediment, which is mainly just polished. It's still scratched up and polished, but it might appear a little sorted. And because of that, this is called a different formation. This is actually called an esker. So once again, what do you really have to know about glaciers? Oh, I do want to show you one more thing. Just to emphasize, you got to know that unsorted sediment, you have to know U-shaped valleys, okay, and you also have to know how to make this thing screen blank. There we go. You also have to know that the different formations of glaciers. I just wanted to show you a picture that I do have showing these valleys. Here it is right here. Thank you for the lights. And this is Mrs. C. And actually, picture is the other way because I know she was on that side. And this is really cool in a valley forming the U-shaped valley, not V-shaped. You see a remnant of the glacier. This thing is called a hanging valley. This is called a glacial tarn, which is a glacial lake. And just really cool. And just to emphasize one more part, there it is, not a V-shape, a U-shape of the glacial valley. And what kind of sediments would I form? See down there at the bottom? You guessed it, unsorted, unlayered. Thanks, guys.